Good afternoon, good morning. So my full name is Joachim van der Zwijn. It's a little bit complicated, that's why the majority of the people refer to me as a man. I used to do lots of asterisk related stuff. I was also the founder of Asterisk Group. This is the whole slideshow, I think. Okay, that's working. Okay, so nowadays I'm leading the development team for sobre. Sobre is a quite popular softphone. I don't know if anybody knows the softphone. Does anybody know sobre? Oh, wow, quite a lot of people. Good, good. Then I won't have to talk about sobre today, but we'll talk a bit about what we found out while developing sobre. Some experiments we did, and it's also based on the feedback we get from customers. So the people are concerned about these things mainly. The first one is the latency. How can you have quality where you can actually have decent latency, meaning the delay between the moment you say something and the other person hearing you should not be too long. We'll go with quality in a second. Second one is how could we get the best quality for your mobile calls? Then how could you have the most reliable incoming and outgoing calls? We will only talk about the signal part here. We will not be talking about the actual media. That's more for the talk for tomorrow. I think that's what the people talking about that business tomorrow. And last but not least, the battery life. How can you make sure that your users can have voice over IP, but the battery life does not suffer too much because it's a bit of a problem for certain ones. So let's start with the latency first. The maximum latency you would like to have for voice over IP is 500 milliseconds, but that's the absolute maximum. You really want it to be less. Ideally, you want it to be like 250 milliseconds maximum. But over 500 will be almost impossible to speak. It's like speaking over satellite connection. Like a long time ago, when you would go from Europe to the States, for example, it would be very long delay. So you don't want it to be 500 milliseconds. So the total latency consists of several parts. You have the network latency. This is, for example, first the 3G part, then from 3G maybe to the PBX and back. Then you have the audio latency. Audio latency is the time spent on the audio device itself. So in your phone, it turns out that this phone is not all that fast to process the audio. And the third part is not that important. It's the algorithmic delay. It's the time needed to compress the packets. For example, the G729 or the Opus. Now, most of the codecs, most of the modern ones, will be about 20 milliseconds delay there. The worst ones are about 60. We won't talk about algorithmic delay. It's a speech on its own, we'll talk on its own. So we'll just talk about network latency and audio latency. These are somewhat measurements for the different popular networks at the moment. Now this is best case. You might have 3G that is 400 milliseconds as well. It depends on the generation. There's like 8 different generations of 3G. There's 700 as well probably. So the actual latency you get depends on the model you have. As you can see, 2G, you won't be able to do an awful lot with it, aside from the bandwidth not being sufficient and having an awful lot of packet loss. The latency, the best latency is already the maximum you want to have. Important to know is that when you make a call, or when you make any type of data connection, unless you're the service provider and you're the GSM provider, and both the PBX or the VoIP switch and the base station are in the same network, you will have additional latency. This is just to go towards the first point. For example, if you take Wi-Fi, this is what it takes to go from my phone to the wireless access point that is maybe in the next room. This is not what it takes to go on a server that is in the US, for example. So we saw the first list. We'll go back in it to it a little bit later. Now look at the latency, the audio latency. We noticed when doing development for sobre that there's actually an awful lot of latency in mobile phones. A lot more than you have in PC. An awful lot more than you have in PC. So we made a little application this year to test how much the latency actually is to be able to recommend to our users, okay, you have a good phone, but you should probably buy another phone, because with your phone you will never have decent quality. Also to recommend what should the settings be that the user needs to put in the phone, what sample rate, what buffer size if the phone allows you to set this. So we made an application and you can actually download it from that website. What it does, it will play a little beep and it will record that beep from the microphone. And it will calculate it or try to calculate it too, and it will tell you what the latency is. And it will do this for different sample rates and different buffer sizes. And this is what the results will look like. Now, if you look at it, you can see that certain sample rates, for example, 44 kilohertz here, has a huge latency. Others might be better, like 142. So this is some of the tests we did with some of the phones in the office. I think we have about 60 phones in the office now for testing. These are just some of the tests we did. Now, when you look in green, everything in green is the best result for that specific phone. So, and usually what is in green will also be the native sample rate for the device that will be reported by the device. So as you can see, the best is about 110 milliseconds. The worst is 822 milliseconds. On average, and these are all results for Android. On average, Android will probably have most of the phones, the recent ones, 200, 250 milliseconds. So it is already quite a lot. iOS, in comparison, so the iPhone will have something like 20 milliseconds. Windows Phone is comparable to Android, it's about 20 milliseconds. But at least on Windows Phone, it's quite stable. All the phones have the same, all the sample rates have the same. On Android, it really depends on what you have. These are the results of the findings. So if you do the test on your own, you will also get some results like this phone is better than 80% of the phones that we currently tested. But what we found is iOS is definitely superior over everything else. The new Android 5 that is about to be released is about 20 milliseconds faster on the phones we tested it on so far, which is mainly the Android, the Nexus 4 and 5, I think. And the more recent your Androids, in general, the better the quality. Now the best phones were Nexus 4, 5 and Galaxy Nexus. They have about 100 milliseconds delay compared to 700 for the others. Something else that you'll see when you do the test, there's a checkbox to enable or disable the speakerphone. When you use the speakerphone, your latency is a little bit more, because it probably needs to do some extra things for record cancellation. So keep this in mind when you do the test. The goal for the tests for the application is for us to get more feedback and be able to make a listing with maybe the 7,700 phones that are currently supported by Google Play, and to really recommend, okay, this is your phone model, this is the Android you should be using, this is the sample rate you should be using. At the moment, we have like 200 tests done, so it's not that much. So, but what is the result of this latency test? It's quite important if you want to make a new business case for a new product, to see what the possible combinations are. When you have iOS, you can do from iOS to another iOS device, no problem. Even if there's 3G in between, quality will always be okay. The latency will always be okay. However, if you have Android and you want to call to the PSTN, to a fixed number, meaning you call from your Android to Elastix, and Elastix will go to the PSTN, probably it will be okay with most of the phones. Most of the Android phones will do it just fine. However, if you want to go from your Android phone through your Elastix to another Android phone, and you're using 3G, and your Android is maybe having 300 milliseconds latency, that's not going to be good. Because you have twice the 80 plus 2 times the 300, you're going to be over the 500 milliseconds, your customers will not be very happy. So I think it's going to get a lot better in 2015 with Android 5, because they finally start to listen a bit to the developers that something needs to be done. But so, at the moment, you're a little bit limited in what you can do. So for termination, it's okay, but for Viper style applications, it won't always be very good. So let's look at the quality. What are the best settings you should use to have the best quality? First tip, do not use Speaks. I know Speaks is very popular. It is a nice codec, but on the fixed point version has a bug. If there's high volume, the sound will be distorted. This issue does not happen on the desktop version because then all the programmers will be using the floating point version. It only will happen on the mobile version. Ideally, we should be using Opus, which is a newer version of Speaks anyway. However, at the moment, Elastix does not have support for it out of the box. It is, however, possible to make it with some patches. And I hope that maybe somebody can be convinced to somehow merge it. I know that Digit will not do it anytime soon because of patent issues. Okay, so Opus has an extra advantage, aside from having the best quality for the lowest bandwidth from all the contexts that we've tested. They also have forward letter correction. That means if you have a little bit of packet loss on your network connections and on mobile, that is quite common. You can already have quite a lot of packet loss as long as it's nicely distributed before your call becomes unusable. If you want to give this a try without setting up a special network, on the Opus website, there are some demo files with 25% packet loss. You can definitely hear something is going on, but at least it's possible to have conversation, which is the most important. If you have a phone that lets you set the cycle rate, actually for the codecs, for the wireless codecs, supposed to let you focus, for example, don't go over 8 or 16 kilohertz. Now you could do more if you have a fast phone, but keep in mind that maybe the person you're speaking to does not have such a fast phone and will still need to decode it and maybe encode it as well. I think for the echo-cancel might not make a big difference, probably most will stop at 16 cancelling anyway. Another important advice to give is when you buy a phone, when you advise a phone to somebody, try to figure out what the native sample rate is. Now there's no lists available that I know of that list all the native sample rates. We hope to at least publish such a list at some point. If we go back a bit, all these phones have native sample rate of 44.1 kilohertz. You don't want any of those. The reason is that most of the codecs will either operate at 8 kilohertz, 16 kilohertz, and it's okay to go from 48 to 8 or to 16, it's easy to calculate, but from 44.1 to go to 8 or to 16 is quite a complicated calculation, and it will take a lot of CPU, and there is some trickery to be done, but the quality will be a lot less, so try to avoid such phones. Another thing to avoid, it's something you cannot do with Zoiper because Zoiper will select the best setting for you for the audio device anyway. But maybe you have a phone that has native 44.1 kilohertz, and you configure the soft phone to use 48, and then you use the 8 kilohertz codec. That means the first part from the native part to opening the audio device, you will not see it in the CPU usage for the soft phone. But this part will go into system CPU. Because the operating system will actually convert from 44.1 to 48, and then you ask it to put it again convert. Also on Android, the sample of the conversion is really bad. It's very bad quality. So you want to always avoid this conversion. Okay, so now we very quickly went through the latency and the quality. So what can we do to have the most reliable calls? As I said, we'll only be discussing the signaling. Media is a big different story. Let's first focus on the outgoing calls. Who is using UDP for their service? There's 3 different network transport types that are common: UDP, TCP, TLS. Who's using UDP? Majority should be using UDP. I see a couple of hands. So I think probably 99% of the PBXs and the web providers today still use UDP. Now there's a little problem with UDP. It doesn't fit completely, so they should say the simplified is complete for the network. When you send an invite, meaning when you start to make a call, there is some codec negotiation going on there. And nowadays, most phones have an awful lot of different codecs, and maybe different codec settings. And because of this, the invite packet can get quite big. Ethernet has a maximum packet size of about 1,500 bytes. If you enable all the codecs in VoIP, you will exceed the 1,500 bytes. But even if you do not exceed it, because you disabled a few of them, maybe this wireless network you will connect to, or this VPN tunnel you will connect to, or this 3G network, will maybe have 1,300 bytes, or 1,200, or maybe 600 if you're very lucky. So what happens at that point? There are several scenarios. Maybe the packet will arrive, it will be cut in pieces. Like this. So let's say that this on the left is the original packet. When it needs to go over the network, it's broken down into little pieces. And it goes to the network, and then it's in little pieces again. Now, ideally, this would be reassembled into big packets. But SIP does not support that for UDP. And UDP itself does not support the assembly at all. So there's no such option. So what would happen is maybe the second fragment will arrive first, and then you probably won't have any call at all until there's another retry to send this packet. Maybe the first part, the biggest part, will arrive, and you will have where it comes from, where it needs to go to, and the first codecs. But the last codecs, or parts of the last codecs, will not be here. And this probably will result in missing video, or maybe codec mismatch and the call will fail, so it's something you want to do. So what's the solution for that? The solution is to use TCP. TCP actually has this reassembly of the packets. SIP does not need to do anything. SIP just gets at the arrival the complete packet again. So it's happy and the call will go. So that's an important thing. Never, ever, ever use UDP for SIP nowadays. However, it doesn't solve all the issues. There's lots of problems with TCP as well. The biggest one is probably that Android drops the SIP traffic on TCP. If the packet is big, Android might drop it. I don't know the reason. It just happens a lot. It's been a bug. It's been reported as a bug, I think, in Android 4.0. But some phones, because of the fragmentation and the different manufacturers, still have the issue. So Android 4.3, 4.4 still has missing packets. It's very difficult because it looks for the application, it looks as the packet is being sent, but nothing is ever being sent to the network. The second part is that some firewalls, this could be your wireless access point, this could be your provider, this could be your network router, will try to be clever and will try to make sure that you have audio in both directions and try to make sure that this complicated SIP packet will be modified a little bit. It's with very good intentions, but in my experience, it never works. All the SIP stacks that are used for SIP ALT are broken, so you might just want to disable it. You do not want this. Now, what if you can't change the network setting, the firewall settings for your 3G provider? Usually that's the case, I think. What to do then? You know how famous this guy is in Latin America? He's sitting back there, his speeches this afternoon. Okay. So it's easy, you should be using TLS. Speaking for him, he's very busy, can't say. In TLS, you will encrypt your communications. That means that your Android won't see that it's SIP traffic, so won't bother. Your ALG firewall or your TV provider will also not see that it's SIP, so they won't bother to modify it. So it's okay. The downside is that it's a little bit more problematic to set up for the user. And a lot of PBXs in the wild do not support because they're not configured to use it. Elastics for sure supports it, but I'm sure the majority of people do not use TLS with it. Now, even with TLS, there are some issues. They're not that big. But if you, depending on the software you use, you might experience some problems for your users. For example, some of the Android phones don't have certificates solved. It's something that's easy to be solved. If you're making a soft phone, like we do, okay, we just bundle our own certificates in there. We have to do the same on Windows 4.8.0 because there's no API to access the certificates. But 8.1 does. And so we also have to bundle those. I think starting today, the Windows Phone version also has support for TLS. So the solution. Aside from using TLS, there's other options as well. You can use TCP on a port that's than 5060, and usually the firewalls will not care. Android will also not care as long as the port is not 5060. Aside from that, it will help tremendously for anonymous calls from people trying to hack into your phone, hack into your PBX, just send you spam calls, etc. Yes, it will break some other things, but I would recommend never use from 5060 for certain. The best solution is to use TLS over 443 or 443 because it will go to most of the firewalls. You could also use X2, although it is UDP. It's more of a binary protocol, which means the codec negotiations is a lot smaller than the packets in general, or smaller for bytes. So we did the outgoing calls. Let's have a look at the incoming calls now. Most people like incoming calls to work. I don't like that feature too much, to be honest. Okay. So let's talk a bit about SIP registrations. Since most phones move around, they will also have different IP addresses. So to be able to receive incoming calls, that's why we use the register packet insert. It's to tell the server, okay, hello, that's me, that's my IP address, that's my port. If you need me, that's where you can find me. Now, this packet takes quite a lot of CPU on the server because there will be some authentication involved. We have to calculate some things, we have to check in the database, we have to update the database. So a lot of providers and PBX administrators will be worried, okay, if we have 30,000 users and all of them are sending us a lot of registrations, the local server will be too high. So what are we going to do? We'll tell the user, okay, you can only register once an hour. We will set a timeout of 1 hour, so it's going to be fine, and everybody will be happy. Unfortunately, it doesn't really work that way. There are reasons why phones might want to register quicker than 1 time an hour. But these are incidents, these are things, complaints we get from users who tell us, okay, with this server, I get the registration failed. Why is it happening? Why are you not compatible with this provider? But yes, we are compatible. But the provider, for example, puts a limit, this phone cannot register more than 3 times per hour or once every 10 minutes. But for example, if you look at my case, I get up in the morning, I turn on my phone registers. I go out of my apartment, I go in the elevator. When I lose the network, the connection will change, I have to re-register the moment I pick up the internet again. Still Wi-Fi, I go to my car, I switch to 3G after a while. Oh, I need to re-register because my location, my IP port have changed again. I go to the office, on the parking, I pick up the wireless. Oh, different IP address, new registration. Go to the elevator, come out of the elevator, oh, again, new registration. I live about 50 meters from the office. So those registrations, it's a valid user case, it can happen. And yes, I do take the cloud most of the time. So, if you want to do some limitations on the registrations, be a bit more fair with it. Use it for a larger duration. Put limitations on how many registers can happen, for example, in a 24-hour period and a several-hour period. Because normally, I will not be driving around all day. I'm in the office usually, so it will usually be okay. The next part. Another common reason to use the registrations is because of NAT issues. So NAT is used to have a lot of PCs sharing one single IP address. And it's using a combination, this is just a slide I took from the internet this morning. So it is some kind of database that will see, oh, this person is behind the NAT, and he's trying to connect to this public IP address. In this case, my internal IP address will be 192.168.0.11, and I am trying to connect to 206.73.118.180. So what will the NAT do? The NAT will assign in between, on the public IP for the client, a mapping. So that for the outgoing packets, it's not a big deal. But so the reply from the server also has to go somewhere. And this mapping on server keeps into account, okay, when I get this incoming packet, I know that it's going to this port, and this port is already allocated, and will be forwarded back to the internal IP address. Now, Unfortunately, there are timeouts. And after a while, this database here, this mapping table, will no longer be valid. So when the timeout happens and a packet comes in, it will be dropped because the server does not know where the packet should go to, where the internal IP is. And this timeout on UDP between 30 seconds and 2.5 minutes. So we could send a register every 30 seconds. In I think 30 seconds, less than 30 seconds happens as long as it's only a few percent of the things. 90% of all the NAT files have less than 2.5 minutes. I think half has about 30 seconds. So you could send a re-register every 30 seconds, but your server provider will not be happy because every 30 seconds, 24 hours, 30,000 users, it's 1,000 registrations a second. It's a lot. The 30,000 users is actually not that much. So there's a solution because TCP has a minimum timeout of 2 hours according to the RC. You can switch to TCP and the problem is gone. You said 1 hour, maybe some additional possibilities there. Okay. There's a problem though as well. If you use TCP, the timeout is not 2 hours. These are some measurements we did. The first time is 3G, 4G, where we set idle TCP connections after 10 to 120 minutes. So at best, on now the 3G providers we tested it on, at best they follow the RC in this 120 minutes. But they might want to optimize the network a bit as well. They might put it to 10, 5, 3, how little, nobody knows. The same with the NAT device you might have at home. But in the office, like Juniper, Cisco, I think is using 30 minutes, not 2 hours. Then another problem, if you look at this mapping. Here. If you have a cheap device, then your database will be very limited. So if you have a lot of devices behind your NAT, or you have a lot of maybe some port scanning going on, some nmap, some torrenting, things that make lots of connections, the complete storage for the database will run out, and the oldest entries will be removed first. So you really don't know how short it's going to be because it will vary. If there is a lot of load, this might be 30 seconds or even less. If there's no load, then it's going to be 2 hours. So how about we solve it again by re-registering for 30 seconds? And we don't care about the provider. The provider just needs to get more servers. It's his problem. It's okay. 30 seconds and I'll be happy to always have it. That doesn't really work either. Because Apple does not let you send packets every 30 seconds. When your cell phone on Apple is in the background, it's actually in hibernation mode. And you're not allowed to wake up, or you cannot wake up the phone, the application, more than once every 10 minutes. That means it's impossible to send a registration from your ZipSoft phone on iOS more often than once every 10 minutes. That's a bit problematic. Okay, so how about we do some other tricks? How about we send an options packet every 30 seconds from the server? Sending an options packet on Asterisk is doing qualify with 30 seconds. I don't know what the configuration looks like on Elastic, but I'm sure there's something like that. It's used to to keep the data alive, and it also tells you a bit about how fast the phone will respond, how the network might be like, etc. So let's just send an options qualify packet from your Elastic evidence. Oops. iOS doesn't like that either, because for every packet that is something that is not just to keep alive, iOS will wake up the application it is meant to be used for. And if there's too many wake-ups in a 10-minute interval, iOS will kill the application, and then there will be no more calls, nothing. How often can you have a qualified packet? Nobody knows. Apple doesn't want to say. It might be different from different versions of phones, might be different versions of iOS. Nobody knows. So don't do it. At the same time, also watch out to publish and notify things for presence. You need to make sure that you do not reach your phone. If the phone is in background, you do not want to send in that information. It's going to use a lot of bandwidth, it's not useful, it's going to wake up the phone, it's going to kill the application, it's going to use a lot of battery, just don't use it. So how about we send a turkey, keep alive, the TCP, no SIP, just the TCP keep alive, every 20 seconds from the server to all the clients. Good work. Seems okay. Server mode will be fine because there's no database operations needed. It's done in the Linux kernel. Bandwidth is very limited. It's not that bad. It is very bad. If you use 3G or 4G, you will see that your battery will die very fast if you send a lot of people life packets. It will be the same on Android. If you try to send in a lot of options packets, where it's allowed actually, you will still see a lot of battery drain. So we wanted to see exactly how much is the impact of those people life packets. How much battery will it eat? So for this, we bought Range Network ZFkit. This is Michael was talking about this in the last pitch. It's a very cool thing. I can only recommend it. I don't know if they have any discount codes today, but very cool thing to have. So we also have a couple of phones. We have SIM cards with all the local providers in Bulgaria. And we have 2 wireless access points. And we were very courageous. We tried to make all kinds of tests that took a lot of time because we went like running for 12 hours, 24 hours, see the difference. And it didn't work. It's very unreliable to do your own testing, and you don't have a special lab to do so with specific hardware that is really up to the task. And where you control both the network part and the client part, where you're both the server, the cell phone network, and the phone. Because it turns out that the settings for the battery usage, the settings that relate a lot to the battery usage, are controlled from the network. And not just based on whatever settings they have, but also how far away you are from those base stations. So we actually used some white papers from Michigan University, AT&T, Nokia instead. This is the most important graph for the 3G network, for the battery. This is the result of sending one packet, one people life packet. So what happens when you're first in idle, it takes a bit of time to spool up, let's say to process that you want to send something. And then you will go to high energy mode, that is a lot higher, it's 100 times more than being in idle. You will send the packet, but then the phone thinks, okay, since it takes a long time to send one packet, to go from low energy to high energy, I will stay a bit on high energy because I'm expecting a second packet. Because normally when you go to a website or you do whatever you do, there is not a single packet. The single packet only happens for people life packets. So it will keep it active, and this will take about 30 seconds usually. It could be less, it could be more, it depends on the configuration for the operator. But that means if you send a packet every 30 seconds, and it takes 30 seconds to go back to idle mode, you're actually using full power non-stop. And full power is 100 times more than idle. That's all of energy. It's not going to be good. This is the situation in 4G. So here you actually have 3 stages. You have something in between. This is the higher energy in PCH, and then you have FAC, which is in between, about 50 times higher, and then you have PCH. This is already simplified. There's actually 4 states. So on LTE, the situation is similar. It just has a little bit less states, and overall it uses more battery. Now you can check on your phone what mode your telephone radio is currently in. At least if you're lucky and you have one of the phones where these codes work on. If you just go to the native dialer, I think most Samsung phones will work with any of those 4 codes, and all iOS phones will work with the last code. If you type in that code and you hit the dial button, on Android you get something like this. And so the direct C state is the one you're looking for. And it will show you PCH, so okay, this one is an idle, that's okay. But if you're sending people life packets non-stop or other data, you'll see that this one will not be PCH, it will be another state, it uses a lot more energy. This is energy usage and idle. So when the phone is not doing anything, there's already a big difference between the different phones. Now again, these are not accurate measurements. This is, let's say, some overall average for different phones, for different providers, for different configurations. But it still gives you an idea that 2G actually uses less than Wi-Fi, Wi-Fi uses less than 3G, 3G uses less than LTE. Now, on Wi-Fi as well, there's lots of different models. LTE, 3G has different models, so the results do vary a bit, but in general, for our purposes, it's good enough. Now when the phone is active, a lot more energy is used, but in Wi-Fi it's not that bad. The difference is not that big. 2G, okay, it's not that big needed. 3G and LTE go up a lot more. But there's something more interesting. On Wi-Fi, when you send the cable live packets, it goes to a little bit more high power modes, but that takes like 250 milliseconds, and then it's back to low power. If you use 3G and LTE, you'll probably have 15 to 30 seconds per packet with high power modes. So that's what makes the biggest difference in energy usage. So if you're on Wi-Fi, if every user if it's a phone that's only used in the office, no problem. Put the key live from their server every 30 seconds, you're going to be fine on Wi-Fi, no issues. Not so much on the others. So how much is the impact? So this is actually the cost. This is the cost for one packet. One single packet you see on Wi-Fi doesn't cost what this is used in energy. 2G a bit more, 3G a bit more, LTE a bit more. So how much impact does it have? What is the optimal setting to have the best energy usage? While the lowest, you have lowest usage on the CPU on the server, and the most reliability. So on Wi-Fi, if you send a packet every 30 seconds, it will cost about 2% more CPU for the more energy for the radio than on either. So it's baseline design. If you are on LTE and you send a packet every 30 seconds, you use 20 times more energy than not rolling at all. Now, the less frequent you send the packets, the better it will be. So you have to somewhat match it up. And I think 600 seconds would be a good spot. We don't know what it will be. You want to have the highest setting possible for your network. So what is that setting? How often should I be sending a keep alive to make sure that every incoming call will always work? So what does Google use? They use notifications, push notifications for their applications. They're supposed to always find us. So let's just take the same settings. This is what they have. Actually, anybody with an Android phone, would you please type in this number and hit dial? On the second one, and the first one doesn't work. And tell me what the result is you get. This is the measurement we don't usually. They will send a keep alive packet every 28 minutes on cellular, so 3G, 4G, etc., and every 15 minutes when you're on Wi-Fi. Can somebody give the try and tell me what the result is in the local operators? When you type in those codes, does it give you anything? Don't worry, it depends on the model again. Okay. But look, if you do try it at home, so please send me the results. I'm very interested. So even if Google has a certain measurement, we still don't know what to use. So we make an application that actually tests how fast this timeout happens, or how slow it happens. And how it works is that it makes one control connection to the server. And on this control connection, we will send packets non-stop. Every couple of seconds, we'll send a packet to make sure this control connection stays open. Then we'll make a second TCP connection, where we will first try for 30 seconds. Do we still can get an incoming packet? Yes, it works. Okay, let's try 60 seconds. Let's try 5 minutes. Let's try 10 minutes. Then half an hour, 2 hours a day. And if we can measure this, then we know the optimal value, and we'll just use that. This application will be available on Android soon. We don't have it there yet. We already tested it in the office. And these are the results we find in the office. So on our wireless, we stopped the test at 15 hours. We didn't want it to be that high anyway. But still, you need these kind of things. These are the 3 different operators in Bulgaria. So we see that the lowest one has about 10 minutes. That's quite interesting. Because this is Google setting. We're on cellular. The timeout is 10 minutes. That means 1 out of 3 push notifications from Google will not arrive on that network. So if you're using Viber or WhatsApp, there is some trickery possible that they do. They actually lower those settings as well. Because the Google default is not good enough. You can find a lot of comments on this with the Google search. So Summary of the talk. If possible, use TLS on port 443. If that's not possible, please contact your ISP or your PBX vendor and ask them if they can enable it. They can. Usually they can. They just don't want to. Push it a bit. If they still can't do it, then at least ask them to give you a port where it's different than 5060 in TCP. That should work. Configure TCP timeout on your server or the client. It is as low, as high as possible, but lower than you need. It turns out that 10 minutes is quite okay for us. I think we have 10 minutes in server. And make sure that the registration timeout on the server is more than 10 minutes, or it will never go live. So you will not have live calls. So you cannot demand faster registration than every 10 minutes on the server. So that's a solution. That should solve everything. Except that it doesn't. You can't do any background calls on Windows Phone anyway. The process can't run, the application cannot run. Can't do anything. So what do we do there? Easy. Push. This is actually a reference to the next speaker today. Maybe they will say something about it, and we'll see. So how does push work? It's a bit strict again. So when you have a phone, this is some slide I took this morning, so I didn't adjust it at all. When you start your phone will contact, in this case, the Microsoft servers. These are the Microsoft servers. It will say, hello, and this guy in the Microsoft servers will return, okay, this is the token for your push connection. It will send it back to the application, and then the application would send it to the SIP server. When there's an incoming call, the SIP server will say, aha, this is a Windows phone. I can't reach this guy directly. I need to send a push notification first. Let's see what the token was that I received for this guy. And let's use the token to send a notification, to send a request for notification to the Microsoft server. The Microsoft server will then send the packet to the phone to instruct the phone, please launch this soft phone. The soft phone will start, or will at least be woken up. We'll register to the server, then the server will say, aha, the guy is finally there, he woke up. Now I can send the invite, and I'll make the call. So it's nice, it works. It's not a battery, because you don't have to use any connections. But in the background, what they are doing is exactly the same as the thing I just explained. They send TCP equalize. They try to be somewhat clever with it. So it's okay, we just do the push. Now, there are some downsides with the push. It takes a little bit of time for the application to wake up. A few seconds, at least. Then you maybe need to do some connectivity checks, check stuff, connect the server, register. There's some other delays there too. The biggest problem now is that it requires some server changes. Yesterday I found some article from some user from PBX in a flash. Nice description of how to configure it with VoIP. It's possible. It's not all that easy, but as a system administrator, we should be able to get it. I won't go too much into details of the changes you need to make on the server. It's a bit of scope. So if you make it for Windows Phone anyway, you would say, okay, maybe if you have it anyway, why not do the same logic for Android and iOS? And it's possible to do so. But it's possible for us to do so. So we could call you, but it doesn't mean you could call yourself when you're using the Zoic application. Why is that? Because the application on iOS and Android, not on Windows Phone. This application here, and this notification, this registration with the push server is per application. So our server, we can have one server for all our users to send the notifications from. But there's lots of users with their own PBXs. Actually, there's no service with Zoic, so you can't even use it. So we cannot wake up your phone like this. So the only solution there is to have somebody to make you a white label version and compile your own phone that has its own push connection to its own push server. So it is theoretically possible. And if you Viber or WhatsApp or you have your own branded white label phone, or you make your own, it is possible. But for everybody else, it is a bit tricky. The biggest advantage, actually the only advantage for using push, is on Android and iOS, if the application is not running, it will be stopped. That's also the annoying part of Skype when you get a message at 5 o'clock in the morning, Skype is not running, and you can't really turn it off unless you go to settings and disable notifications for Skype. Then you then have to re-enable the next day, because otherwise there's no incoming calls. So the best solution is a combination of both, if you have the possibility to do so. Does anybody have any questions? No? I know there's somebody down there with some questions for Zoiber. Okay. Thank you very much.